Hey everybody, Mr. Rubo here. Today we're going to talk about polynomial long division. Um, so this is really the same algorithm almost as normal like numeric long division. So long division with numbers, it looks very similar. I personally think it's actually easier than numeric long division, but yeah, we'll see. So here, if I were to say I want to do x cubed plus 7x squared minus 49, and if I want to see if something is a factor, so specifically x plus 5, I'm going to do long division. Okay, um, so I'm going to set it up just like you would long division with numbers, and yeah. Sometimes though, it's more so just for sake of like keeping everything neat. If you're missing a term, so like here we have 7x squared and then it just goes right to the constant term, you could leave a space or you could put like plus 0x. It's nice to have that placeholder there. It's actually not completely necessary, but it might help some of you. So I'm going to put it in just for sake. All right, so now the way polynomial long division works is you always look at the leading terms. So you want to think, what do I need to multiply x by to get x cubed? And hopefully you say x squared. All right, so now, just like in number long division, the next thing you would do is you would take this thing and you multiply it by the number. Well, here we just have two terms, so we just have to make sure we multiply to both things. So x squared times x is x cubed. X squared times 5 is 5x squared, and it's positive, so there we go. All right, so now, just like in regular long division, you're going to subtract, but we're subtracting this whole thing. So we're going to do x cubed minus x cubed. So those go away, which is great. And then you're going to do 7x squared minus 5x squared, which is 2x squared. And then everything else you just bring down. Like I said, you can have the 0x. We don't actually really need it here, but we're going to leave it for now. All right, so now the next thing is we do the same process over again, but now with this new leading term. So now we want to think, how do I go from x to 2x squared? So I need to multiply it by positive 2 to get the 2, and then an x to get x squared, and then you multiply it. So 2x times x is 2x squared. 2x times 5 is positive 10x. Then we go ahead and do our subtraction. That should always cancel. 0 minus 10x is negative 10x. Bring down the 49. And then our last step is to look at this term and this and the x. So to go from, or to multiply x by some number to get negative 10x, well, that would be negative 10. So you multiply it out. Move this down a little bit. So when you multiply negative 10 times x, negative 10x. Negative 10 times 5 is negative 50. And then we subtract. So be careful with your negatives. So that's negative 10x minus negative 10x. Those cancel. Negative 49 minus negative 50. So like plus 50. So we get 1. Okay. So this right here is our answer, x squared plus 2x minus 10, but we ended up with a remainder of 1. So you could say, oh, well, this is our remainder, just like we would when we first learned long division. But we can actually also throw a little fraction at the end, so that remainder would be plus the remainder, which is 1, over what we divided by, so x plus 5. But depending on the question, you might, because like the question I pulled this from, it just asked was x plus 5 a factor of x cubed plus 7x squared minus 49. In this case, we would say no, because it had a remainder. So in order to be a factor, it would have to be a remainder of 0. Wasn't the case here. So it would not be a factor, and this would be what would happen when we divide. All right, so thanks for watching, and have a good day.